Hello everyone, I am from the Tapovan classes. Now today we are going to discuss some topics which is belonging to important for class 12. This is physics classes for 12 class light. It is light is the part of optics. So today we have discussed what is light and what is the characteristics of light, what is the important term which is useful to us, and how to learn. And a very quick topic is given here. So we are going to capture in a minute. How can you understand what is light? Light is a form of energy, and it is produce the sources of light are the three types. So light is a form of energy and it is produced by a luminous particle or luminous sources as like a natural sun. So here is some characteristics of light. There light waves are the electromagnetic waves whose nature is transverse, and the speed of light in the vacuum we better know from a standard 7th 3 into 10 to our 8 meter per second, but it is the different media. Reason behind is whenever we are going to move the light, it's a some characteristic like wavelength. So whenever the wavelength will be change of the light, that is meant by the speed of light is also low. So important term is the luminous object. So the two terms we have discussed in the first part, luminous object and non-luminous object. What is luminous? The object which emits its own light. As for the example, the nature's sun, stars, these have the own lights, that's why it is luminous object. And what is non-luminous object? The object which do not emit own lights, it's become visible due to the reflection of light. As for the example, the natural non-luminous object is the moon, and the non-luminous object at the bulb, electric bulb, and tables, trees, all these things are non-luminous object. Now we come on the term ray of light. What is? It's a line drawn the direction of propagation, that is called the ray of light. And the bunch of light is known as beam of light. How can image form? And there is a three diagrams is here: parallel beam of light, divergent beam of light, and convergent beam of light. So first we understand what is the parallel beam of light. It is a straight line way of the light is known as parallel beam of light. The second point is divergent beam of light. Diverge, that is meant by start from the first point and move from the different sections, that is divergent. And convergent, whenever the light is come from a different section to a point, it is the convergent beam of light. So these are to understand. So whenever light is spread from the sun or from the electric bulb, that is divergent light. Okay. Whenever the sources of light is come in the same one point, that is a convergent beam of light. Now images. What is images? We have the lots of question about the images. If light ray coming from an object and object appears to meet at a point after reflection or refraction, then this point is called image of the object. Basically we understand the reflection or refraction from the standard 6, but images is also start from the standard 6 also. But image has also the two types, real image and the virtual image. The real image, what is the real image? It's a light called real image can be obtained on a screen, that is known as real image, and it is inverted. What is virtual image? The image when light rays are not really meeting but appears to meet only is called a virtual image. Now we come on the point reflection and refraction. So examination of 12th is on the head. So how can we understand the laws of reflection? There are two laws of reflection. Okay. First laws is the incident ray or the reflected, the incident ray, reflected ray, and the normal at the point of incidence. All three lies in the same plane. That is meant by a plane which is given as here plane mirror, like that plane. So the incident ray, the reflected ray, and the normal. This is the section. It is a plane, so it is first line is become on the source of light, that is incident ray, and the ray is transfer from the here is a reflected ray, and it is the normal, all which are in the same plane, lies in the same plane, that is called reflection. That is called first law. Second law, the angle of incidence. So there is the angle of incidence, here is the angle of incidence, angle of reflections are equal, that is known as second. The angle of incidence and is always equal to the angle of reflection, that is meant by we can say the angle I is equals to angle R. And what is the type of reflection? There are two types, regular reflection and irregular reflection. Regular reflection, that is meant by the parallel beams of reflected. So you can see that, so that here is the diagram is given, but the lots of beam of light is coming from different sections and become on the plane, and that is reflected in this way. So when a parallel beam of reflector, these are the parallel beam reflected the light rays, here is a source of light, is often from the parallel beam of incident light rays after reflection from the plane. A reflecting reflection is called regular reflection. This reflection is known as regular reflection. Now become on the point irregular reflection or diffuse reflection. Whenever we are going to a water sections, that is these types of surface, what will be happen when this non-parallel beam of reflected light, this is the beam of light is come from the hair, and the different sections and different angles is made by the this beam of light, what will be happen? This is irregular surface. So in irregular surface, incident ray come and reflected ray is out from this section. What is the known as irregular or diffused reflection? So we can say that when a non-parallel beam of reflected light rays is often from a parallel beam of incident light ray after reflection from a surface, then such type of reflection is called irregular reflection. Is that clear? Now become a point, how can we understand the plane and how can we understand the incident ray and the reflected ray? So basically we are coming from the 6-7, we are using, whenever we come on the part of the plane, then we are written there is a plane and the name is dash, correct, and the incident ray and the reflected ray. So these section is coming here also. So what we are taking M and that is meant by mirror is here. Mirror, a smooth and a highly polished reflecting surface is called mirror. We have the question, what is the mirror? So a smooth and highly polished reflecting surface is called mirror. The types of mirror, we have the question, how many types of mirror? So plane mirror and surface and a spherical mirror, as well as plane lens, spherical lens is available. And here mirror is two types, plane mirror and spherical mirror. Plane mirror, a highly polished plane surface is called plane mirror. Different properties of plane mirror also. What is the different properties? We have come from the different sections and only remind the capture these points. Size of image of object. What is the size of image in plane mirror? The size of object. What is the magnification? That is unity. The distance of image is equals to distance of object. So in a plane mirror may form a virtual as well as real image also. A man may see his full image in a mirror of a half height of man. It is very important to day-to-day life. We are using whenever we are going to make any party and make a makeup in yourself, how can we are going to show yourself? A plane mirror may form a virtual as well as a real image, and a man may see his full image in a mirror of half height of man. So when two plane mirrors are held at an angle theta, the number of images of an object placed between them is given as below. So whenever the angle form in a plane mirror, so what its work, n is equals to 360 degree by theta minus 1, where 360 degree by theta is an integer. N is equal to integral part of 360 by theta when 360 degree is not an integer. A plane mirror may form a real image when the pencil of light incident on the mirror is convergent. Children during their play form an image of sun as wall by a strip of plane mirror. So it is very useful whenever we are doing these things. And kaleidoscope, you better understand what is the kaleidoscope. And periscope employ the principle of image formation by a plane mirror. So if keeping an object fixed, a plane mirror is rotated in its plane by an angle theta, then the reflected ray rotates in the same direction by an angle 2 theta. So it is the two example, kaleidoscope and the periscope. These are the two equipment which is used to understand how plane mirror makes images. Now we have a question about the focal length in plane mirror. So what is the focal length as well as the radius of the curvature of plane mirror is infinity. Power of a plane mirror is 0. An image formed by a plane mirror is virtual, erect, laterally inverted, of same size that of the object and same distance as the object from the mirror. Now we come on the point spherical mirror. There is a two types, a concave mirror and convex mirror. What is a spherical mirror? Highly polished curved surface whose reflecting surface is cut part of a hollows at glass sphere is called a spherical mirror. Spherical mirrors two types, concave and convex. A spherical mirror whose bend in the surface is reflecting surface is called concave, and the spherical mirror whose blugging out surface is reflecting surface is called a convex mirror. So here is two diagrams. We are using the concave mirror and convex mirror. The same terms of a spherical mirror are given below: the center of curvature, radius of curvature, pole and focus. Center of curvature capital C, radius of curvature capital R, pole P and the focus F. Focal length is small f, of focus is capital F. These are the small representation of these sections. What is the center of curvature? The center of a sphere which the mirror or lens is apart, and the radius of curvature, the radius of hollow sphere of the which the mirror is apart. And the pole, the central point of a spherical mirror is called pole, and the focus when the parallel beam of light rays is incident on a spherical mirror, then after the reflection it meets and appear to the mid at the point on the principal axis. That focus of spherical mirror is called focus. So the focal length, the distance between the poles and the focus, is known as focal length. That is represented by a small f, and so we can written mathematically small f is equals to capital R by 2, and the power of mirror is P is equals to 1 by f meter. Now become the mirror's formula, that is known as very famous formula. It is the mirror formula. We are coming from understand to this point from the standard 10th. So 1 by small f is equals to 1 by v plus 1 by u, where f is what is the small f? That is the focal length, u is the distance from the object, and b is the distance from the images, which is given in this diagram. And the Newton's formula for the concave mirror, Newton's is discussed about the concave mirror sections formula, and f is equals to under root x1 x2 and f square is equal to x1 x2. Very easy. We understand from the mathematically f is equals to when we are out of the root, then what we have written, the f square is equals to x1 and x2. That is very easy. x1 x2 is the distance, where x1 x2 is the distance of the object and images from the focus. There is distance of object from the focus. Now the magnification, the ratio of height, that is meant by image formed by a mirror to the height of the object is called linear magnification. Linear magnification m is equals to I by O, that is minus b by u. And the aerial and the axial magnification, there are two types of magnification, aerial and axial. The ratio of area of image to the area of object is called aerial. So how can we write the mathematically? M square is equal to b square by u square, and m square is equals to area of images by area of object. When the small size object is placed linearly along the principal axis, then its longitudinal and the axial magnification is given. What is the axial magnification? That is meant by, we have using calculus, that is minus dv by du. B, that is meant by basically b, and by u. U is object and b is images. whole square is equals to, whenever putting the value of dv by du, and we are getting f by f minus u whole square is equals to f minus b by f ka whole square. So sign convention is useful the spherical mirror. So we are going to use here. First, all distance are measured from the pole of the mirror. Distance measured in the direction of incident light ray are taken as positive, and distance measured in the opposite direction to the incident light rays are taken as negative. Distance measured above the principal axis are positive. जब भी हम distance को measure करते हैं principal axis के above तो positive हो जाता है, और जब भी below करते हैं तो negative होता है. Two terms, जैसे ही हम करते हैं above and below, the above means positive, below means negative. Now lateral inversion. So we better know about lateral inversion. It is image is formed by a plane mirror. The right side is left side appears the left, and left to appears to right. That is known as phenomenon of the lateral inversion. That is nothing, but it is important to understand when an image is formed in the plane mirror. When an object is placed between the pole and focus of the concave mirror, which kind of image is formed? Virtual, erect, magnified. A convex mirror form a virtual, erect, diminished image for the all conditions of object. Not only one conditions, all conditions, whether object on the center of curvature or the between the center of curvature and focus, and either focus. So the focal length of the concave mirror is taken negative, and for the convex mirror taken as positive. We are putting the 2 points. Always focal length of the concave mirror is taken negative and convex mirror taken as positive. So these are the 2 points, and very easy to understand how to convex mirror formation of image: virtual, erect, diminished image, all conditions, all other conditions, not only one conditions. Now refraction of light. It is very important to understand refraction of light. The deviation of light from its path when it's travel from one transparent medium to another transparent medium, that is called reflection. Already very and easy to understand. There is the two transparent medium. One is air and second one is water. So when the light is come from the one incident rays come from the one transparent medium to another transparent, it's bend their path. Yes, is literally here. Path when it's travel from one transparent medium to another transparent medium is called refraction of light. This section is known as refraction of light, and it is the normal is available in either first and second conditions. So incident ray and reflection, there is the interface of two media. First is air and second one is water. That is the cause which is basically, we have discussed before, the speed of light in different media. So there is a two laws of refraction. First the incident ray, the refracted ray, and the normal at the point of incident. All three lies in the same plane, and the ratio of sine of angle of incidence to the sine of angle of reflection is constant for a pair of two media. So we can write down sin I by sin r is equals to constant. That is 1 mu is written here, 1 mu 2. That is meant by, what is 1 and what do you mean by 2? 1 means first medium and 2 means second medium. It is second medium. First transparent medium to second transparent medium. One is rare medium and second one is where U1, U2 is called refractive index of second medium with respect to the first medium. So this law is called Snell's law. It is very famous law which is used in the physics section. Snell's law. Refractive index, the ratio of the speed of light in vacuum to the speed of light in any medium, is called refractive index of medium. So what is the refractive index of a medium? Mu is equals to C by V. C means what? C means speed of light in vacuum, and V means speed of light in given glasses, given transparent medium. That's why the time taken by light to transverse thickness x of the time, and we have written here mu x by c, where c is the velocity of light in vacuum. And this section is going to take a first. How can we formulate it in a mathematical section? V1 by V2 is equal to height by object by height by image, and this formula is becomes to formulated by Cauchy, and very important Cauchy's role on this section. The Cauchy's formula is refractive index index of medium mu is equals to a plus b by lambda square plus c by lambda 4, where lambda is equals to length of light and refractive index mu is directly proportional to 1 by lambda square. Now we come on the point is a critical angle. What is critical angle? The angle of incidence in denser medium for which the angle of refraction in rarer medium becomes a 90 degree. That is known as critical angle, and it is denoted by capital C. And critical angle of diamond is 24 degree. Critical angle of glass is 42 degree. Critical angle of water is 48 degree. Refractive index of denser medium mu is equals to 1 by sin C. That is very understood, very important term is critical angle. What is it? It is an incident or denser medium. Both are transparent medium. Or when the angle is formed, light is come from the first to second, it's become the rarer medium to 90 degree. That is known as critical angle. Now the term is TIR. What is it? It is a total internal reflection. How can we understand it? Whenever is become on the light is traveling from the denser medium towards the rarer medium, the incident and the interface at the angle of incidence greater than the critical angle, then light rays reflected back into the denser medium, and this phenomenon is called TIR. That is meant by total internal reflection. This is the diagram. So denser medium and the rarer medium is given here. It is denser medium, it is rare medium, and the total all the reflection become on the same point. This is known as total internal reflection. The refractive index is maximum for the violet color of light and minimum for the red color of light. It is very important. That's why we have written CV and CR. The total internal reflection occurs if angle is incident in denser medium exceed critical angle. The total internal reflection occurs if angle of incidence in denser medium exceeds critical angle. So mirage is so this is point raise a point, that is mirage, and it's an optical illusion. The question is become in our brain, what is optical point? So next classes we have discussed upon the optical fiber, okay, and we understand what is optical instrument also. Thank you.